All right. Good night, everyone. Especially to my students, uh, those who are doing E11, and especially it also will be sitting for the examination in the coming month of October. Right. I'm just doing a trial video of solving some exam questions, which I'm going to be posting on my probably TikTok or YouTube channel. If you have a smartphone, you can uh, search, and I'll direct you to go to my channel and have a look at some of my videos there. This is just a trial. For this question, I'm going to help solve this question. It's in the 2019 year 12 exam paper. The question 31, 30 ABs, uh, A and B. So let me just start by with this one. This Since it's just gonna take a short time, so as a trial, let me start with this one, and probably later on I can go up to the first one, part A. Right, this one is a question that is asking us to find the velocity of the here. Calculate the velocity v after the collision, assuming velocity to the right is positive. That means this is a momentum problem, collision problem, where involving two moving objects that are in motion. They're traveling towards uh, one to the right and the other one to the left, and somewhere in here they happen to collide. So when they collide, momentum is going to be conserved, right? So in this case, uh, they will stick together, as it states here. The diagram shows two trolleys of mass 10 kg and 20 kg. 10 kg, 20 kg, that are able to move in a straight line on a horizontal surface. Trolley X, this one, is moving with velocity given 15 meters per second, and trolley Y is moving with the velocity of 10 meters per second towards each other. Right now, after a while they collide. After the collision, the trolleys lock together and move with the same velocity v. Alright, with that problem, we are told to do two things. The first one is to calculate the velocity v after the collision, assuming velocity to the right is positive, and in which direction do they move after the collision. So there are two things that we are going to find relating to this question. Alright, to solve this one, we firstly have to know the formula. Alright, the formula for this collision problem is M1, which is also going to be given in the formula sheet on the exam paper, plus M2 U2 is equals to M1 V1 plus M2 U2. Alright, this basically means that the momentum of these two bodies, this is for A and this is for B, the total momentum before is equals to total momentum after. Okay. Momentum is conserved. So that is why we have this relationship shows that momentum is conserved. Right? Since these two uh, objects are going to collide and have one velocity, we rearrange the formula to look like this: M1 U1 plus M2 U2 is equals to, okay, this is going to be, sorry, it's going to be V2. The U are the initial velocities, right? These are the equations. This is the equation that is going to be rewritten V is going to be common because they are going to stick together after the collision. So that is why we are going to bring V is common out of the equation here, and we write M1 plus M2. So this is the rearranged form of this one, nothing new. Alright, so in here we know that M1 is given, M1 is given there. Okay, in the problem you know that M1 is equal to 10 kg. Okay, U1, the initial velocity before the collision, is equals to this one, is equals to, as we have already seen, to the x, this is 15, and M2 is also given there, it's 20, and this meter per second, this is kilograms, and the U2 is also given to be 10 meter per second, 10 meter per second. Alright, now with all those given, we plug it into the equations given in here. This whole purpose is to find the common velocity after they collide and stick together. Alright, so here we go. M1 is 10 kilograms, so we just kind of disregard the unit just to for convenience sake. Later on we will write the final units. M1 is 10, U1 is 15. Okay, 10 to 15 plus, okay, in here the M2 is 20, and U2 is 10, but it is going to be negative because it is moving towards the left. It's moving towards the left, so it's going to be times negative 10 times negative 10, okay, which is equals to V, and 1 plus M2 is basically 10 plus 20. Okay, so now we have all our quantities plugged into the equation. So now we do straightforward calculation. This is 150, okay, plus 20 times 10 is 200. It's going to be minus, plus, negative here is minus 200 is equals to V total 30. 150 minus 200 is minus 50 is equals to V 30. 30V divided by 30 on both sides. 30 on both sides. Okay, our V is equals to negative 1.6 something meters per second. This is the final velocity. It's negative. Alright, the second question asks, in which direction do they move after the collision? Okay, that is the part 2, and that is going to be, direction is the negative direction, meaning to the left, or in the direction of the 20 kg object. So these are the two. This is how you solve this question. It's a question that was that appeared in the physics 2019 paper. Question part B, short answer questions. Question 31 B 1 and 2. Okay, so here is just my sorry for the poor quality of the recording, but it's just a trial. As time goes on, I will be I'll be making more videos like this to upload on my YouTube channel, so that students can year 2 students who are preparing for the end of year exam coming up in October, will, at least my students especially, plus the 4th students too, who are also with access to smartphones, can at least, you know, look up my channel and see how the working out are done, exam papers are attempted, and that would probably help them to prepare for the coming exam. Thank you.